Okay. Good afternoon, ladies and engineers. My name is Ville Miettinen, and I'm the current chairman of ACM SygsGraph Helsinki. And it's my great pleasure to welcome all of you to SyysGraph 2012. I want to give you a bit of an understanding behind the various acronyms I just mentioned. So let's start with ACM. ACM is the Association for Computing Machinery. It's the world's largest and most prestigious educational and scientific computing society. It has more than 100,000 members worldwide. Going further, ACM is organized in a number of SIGs, or special interest groups. There are 37 of them in total. And ACM SygsGraph is the special interest group on computer graphics and interactive techniques, and it's the largest of all the SIGs. SygsGraph then is organized into 50 local chapters. 30 of them are what's called professional chapters, and the others are student chapters. And we are the local professional chapter of Helsinki, but as it's the only chapter in the Nordic region, we're basically servicing the whole area, and we have a couple of hundred members. So what we do at ACM SygsGraph Helsinki is that we organize 2 graphics seminars every year, GrabCad and SyysGraph. And for those of you who are not familiar with our Finno-Ugrian barbarian tongue, that means spring graph and fall graph. And this one today is the 14th seminar we're organizing, so there's a fair bit of history behind all of this. What we do is that we gather the leading minds in the local computer graphics and interaction community, and that means academia, so researchers, students, teachers, various tech industry people, so that's programmers from gaming and middleware and tools companies, graphics hardware manufacturers, mobile industry, as well as artists from the gaming community, production graphics, movies, and then various hobbyists, for example, from the demo scene. And at ACM SygsGraph Helsinki, we take a pretty broad view of graphics and interaction. So we often invite people from our sister disciplines, for example, computer vision people and human-computer interaction people. Our goal is that we let you hear about the latest and greatest innovations that's been happening in the local scene. And usually we have a couple of foreign presenters coming in. This year, I think we have 5. Now, this year we are doing this in cooperation with Slush. And you might ask why, but the main reason is that computer graphics and gaming are really one of the backbones of the Finnish startup scene. So if you're looking at some of the really superstar startups we're having right now, Rovio and Supercell and many others, they come from this community. And the last couple of events we've organized together with Startup Sauna, so we've been having them at the Aalto Venture Garage, but that turned out to be a bit too small for us, and we decided to cooperate this year. Whether this is the right thing to do or whether we're going to do this in the future, I don't know. That's for you to decide. So if this works or doesn't work, tell us. So in today's audience, we don't only have the graphics people, but we also have various entrepreneurs, international investors, and international media. Today, we're going to have 17 presentations, and they're divided into 2 sessions, 1.5 hours each. And we've recently, over the last couple of years, moved into a format where the presentations are really short. They're 10 minutes exactly. And the idea is that the presenters are just able to scrape the surface, and we're not going to have time for Q&A between the speeches. So if you're really interested in something you're hearing about, grab the presenter during the break. And I have Zaira here, down there. She'll be showing a timer for you and counting down from 10 minutes to 0, and I'm going to cut you short at that moment. So, okay, so today's program, let's take a look. We're going to start out with one of the coolest interaction devices I've seen in a while, followed by some wicked CAD stuff, and then take a quick look at the advances in production rendering. Then there's Joe Robbins from Unity, the world's leading gaming graphics middleware. We're going to take a look at quality assurance in mobile graphics, some Kinect interaction stuff, look at the state of the art of HTML5 graphics, and then finish off the first session with large-scale audience participation games. So we're going to have a break during which there's going to be demo tables, I believe, over there from some of the presenters and others. There's lunch is being served till 4 o'clock, and you have a chance to mingle a bit, and we're going to continue at 3:30 sharp. In the second session, we're going to have a really quick word from our sponsor, then take a look at the state of the nation on the research front, and some modern data visualization techniques. Antti is going to give some highlights from the annual SyysGraph 2012 conference. We're going to take a look at visualization techniques in architectural settings, and then big graphics data in the world of robots and computer vision. And then some insights from the makers of one of the best-selling games on iPad right now, and then finally finish off with 2 graphics hardware-related talks. Afterwards, there's additional opportunities for networking. There's snacks, there's drinks, and at 9 p.m., there's a huge after party. You're all invited. I believe there's sauna and general mayhem. What I would like to do at this point is to give a big hand to all the people who made this possible. So we had a sponsor this year, Qualcomm Ventures. I want to thank the current board of ACM SIGGRAPH Helsinki, and then Zaira, Charlotta, Risto, other startup sauna people who made this fantastic event possible. So thank you. And now I would like to invite the first speaker, Lasse Korpela. Please come on stage. He's the co-founder and one of the innovators behind the world's first true audience microphone, the CatchBox.
There's your problem. Okay, now it works. So I'll just find my presentation here, then we'll get started. I don't use Mac, so. Thanks. So today, that's not good at all. All right. So today I'm going to tell you a short story about CatchBox. And before that, I'm going to introduce myself. So my name is Lasse Korpela. I'm one of the co-founders. My background is I've been studying information networks, which is a cross-disciplinary program in Aalto University, and basically it contains software, hardware, it contains sociology, philosophy, aesthetics, design, user interaction, all that good stuff. So that's my background education-wise. I've also been always interested in hardware, in technology. I like embedded electronics. I like to tinker. That's my background. And I've been working for years in Aalto University in various research projects. I've been a project manager in a project where we did live biofeedback in virtual environments. We've done stuff with virtual environments otherwise also. And that's my previous background. And now this current venture started actually in spring, and it started with an idea. And the idea came in an event in Taik. It was a design entrepreneurship seminar, which was arranged in the Samposali. There was literally like 600 people in the event, and it was packed. And people really loved the content of the event, but the speakers were not that good. They were actually talking about their product, about their business model, about X, Y, and Z, but not about the things that people liked. So what happened is that there was a lot of questions. There was so many questions that there was literally 50 people with hands raised. I was sitting in the corridor and watching this one stick mic, just like this, traveling around the venue, and it was really cumbersome, slow, and didn't really work. And my first thought was, why don't they have a throwable microphone? And well, then my second thought was, have I seen a throwable microphone? Well, actually, then I had to Google, and there were no devices available. So the idea came from there. So like, I thought that throwable microphones, maybe there's something to it. So I forgot the idea for a while. Then I talked about it with our awesome team, and I've been working with these guys with other projects, and we've done a lot of brainstorming, figuring out what we could do business-wise, and we ended up applying for summer startups with this product. And with this idea, we actually got accepted to the Summer Startups program, and everything started from there. So in June this year, we started this 2-month program with that is basically entrepreneurship education and condensed product development period. And it was really good because it allows you to focus on one thing, and it allows you to work in a group of people that are supportive, that actually know what they're doing. We had a lot of coaching and stuff like that. And so for me, the most interesting part of the project was prototyping. And we went about this in 2 ways. We actually started prototyping directly on the original idea, and then we also explored the problem and the space we're working on. And basically, it was a lot of, wires, a lot of foam. We basically went through all of the BR toy selection within 2 weeks. I think one of the favorites was the air fist you can see here. It was a fun period. But at the same time, when we played around with the idea and developed these fast prototypes, we actually went through all of the possible use cases and clients and users, and tried to figure out what is the actual problem. What is the actual problem we're trying to solve? And what actually struck me the most in the summer was that actually I learned that it's not about making something perfect, like figuring out this is the perfect tool for this solution, and then we come out and everybody will clap. But actually, it's like you need to fail fast. You need to experiment even faster. You just need to get out there and test these things out. So we basically made MVPs, 10 of them, and we just used them in events. We gave them to people and saw their reactions. So how did we end up with the solution? We kind of went about it in multiple ways, and there's technology. But actually, more interestingly, I think why it works is that there's an element of softness and element of kind of emotion to our product. And I personally feel that that's one of the reasons why it has been received so well. So under each suit, there's a kid, Many people have children, they go home, they play video games, There's fun and games behind all of these, corporate suits and corporate attire you have. And that's actually something that we feel is one of the interesting things about our product. It's playful. And also, I just had to add this. There was a study in Travelodge in UK, hotel chain, that 25% of men packed teddy bears on their business trips. And I really don't believe the numbers here, but it actually shows that, what you see on the outside is actually not what resonates on the inside. So that's probably one of the reasons also that, our product works in the users. So what we did is we created the world first audience microphone. And as you can see from my shaky hands, this is actually a bit of a cumbersome device. If you know how to use it, you can use it well. It's good for singers, it's good for presenters, it's good for people who want to direct discussion, and it's an element of power. But this one, it's soft, it's fun, it's cuddly. It's something that it's easy to take as your own. It's not cold and sweaty. It's something that is made for people. And the product is now a few months old. It's not ready yet. We're renting it out to people around Finland, and we are furiously taking it to manufacturing. But it's just a second. Yeah. So. The response has been, tremendous. We have returning customers, and everybody has loved it in some way or form. Many people have said it should be round, but we feel that this shape is actually way better, because there's a few things about it. It's easy to grasp, it's easy to hold, it's easy to understand where to speak. Rather than with a ball. And with a ball, you have a tendency to kick it, to throw it, and actually we don't want that to encourage that. We want it to be throwable, we want it to be soft and safe, but it's not an extreme sports tool. So this is one of the reasons behind our product. One of the things is that there's a fine line between a soft plush toy and a crowd engagement tool, and our designer was he stressed about it a lot. And I think we came up with a pretty good solution for the problem that we saw. And the problem is that, if you have a question, this is the tool to use for Q&As. And also, if you have brainstorming, if you have these kind of sessions, it's a good tool for crowd engagement. So as a end note, people have been asking, like, why don't you have this? Why don't you have that? Why don't you have a business card holder? And I just feel that you need to keep things simple. Don't overestimate your users. Never underestimate them, but don't overestimate them. Make it as simple as possible and make the technology in a way that it's invisible. The technology in this one is actually embedded. It's there. If I drop it in the ground, it won't make a sound. But when I pick it up, if the AV guy will, it should work. So the technology in the product is invisible. It works. It's patented. And thank you.
Thank you. And could I then get Kristina Narusk on stage? She's the dev team lead and the country manager of GrabCad, and she comes from Estonia. And she's been bringing in common sense to software development teams for the past 10 years as a product manager and a team builder. And now she's creating a product for all the world's mechanical engineers. So, Kristina, the stage is yours.
Okay. Hello, everyone from Estonia as well. It's a pleasure to be here, and it's good to see so many people around here listening to the presentations. I'll go straight to the topic. As Ville mentioned, GrabCad is about changing the world, one engineer at a time, and that's how we do it. So GrabCad today is about 300,000 mechanical engineers. GrabCad is about tens of thousands of CAD models and millions of interactions between engineers all over the world who share their experience and knowledge in a website and community that we've built so far. GrabCad is also sharing and spreading your knowledge. And by doing that via GrabCad, we actually want to transform how things that you see all around in this room and in the world are being built. It's not easy, but we are giving a shot. And here is one example how these things are actually moving and going on. There was one engineer who convinced another engineer from different parts of the world to start building a fantasy city. They created the first blueprints, very first abstract 3D models, and engineers, one by one, group by group, started to become involved in this project. The very first idea of this fantasy city was modeled out, how big it should be, how many buildings there should be, what sort of infrastructure this fantasy city should include. And engineers all over the world engaged in this project started to work on it. The tools that GrabCad today provides and that we are constantly building actually enable live communication between the engineers. 3D viewers actually allow everyone to see what is going on, what blocks, what buildings, what houses are being built. Here you can see that some engineers thought that, okay, one skyscraper should be a few floors higher to enable some helicopter helipads on top of the ceiling. And this is how they communicate. They do changes on the fly. Everyone sees what's going on. And it's a totally different agile way of developing things that previously had been done very separately and using very rigid and overhead-causing processes. Of course, every city has to have its football stadium, so an engineer came up with that. Chat was going on whether it should have open roof or closed roof, and it got done. Another engineer thought that this fantasy city should definitely include an indoor bungee jumping building. The house was built to show everyone how it will look like in the sunshine and in sunlight. There are very simple tools in CAD software nowadays to enable the buildings and the environment to be shown in real environment as it looks in real life. So almost 30 engineers worked on this project for a couple of weeks. The result came together building by building and block by block. And everything could be seen with just one mouse click in a video stream, how this fantasy city looks like. With one click, you can download all these buildings with all their CAD models, how they actually should look like in real life. And basically, the project is done. GrabCad also favors a lot of sharing the knowledge. So once these almost 30 engineers have built something, and if it's really important and usable for the community, everything can be actually shared open source, so that as many engineers around the world can give their opinions, what they think about stuff, reuse some blocks or some parts of these models that some other people on the opposite side of the world have been built. And everything can be downloadable. So basically every single item that you see in this room and in this building has been built by engineers. GrabCad wants to change how these things are being built. And we want to replace all these very clumsy processes and clumsy software for something much more convenient for everyday users and these actual experts who do this work for all of us for use. So check us out, and if you think you have something to provide or complement on this fantasy city, then GrabCad is the place to contribute. Thank you.
Is on mic on. Okay, so we have actually a bit of time for questions right now from the audience because Kristina was so swift. So if someone has something to ask, please go ahead. Well, at least I have one. How much are you guys interfacing with the 3D printer and like maker community? Is that very close to you guys, or?
Actually, quite a lot. Because what GrabCad also does is that every time some engineer uploads some of his models that they've been building on their free time, there is specific CAD file formats that all these 3D printing services and printers use. And the community and the product actually supports that you can download all these models in as many formats as possible, including the STL formats that are usually used by the 3D printers. And another thing is that we very often have engineering challenges that are targeted towards mechanical engineers. And 3D printing challenges are extremely popular. So we have competitions for models that could be 3D printed afterwards, either then put on sale or something to do something like that. So yes, we definitely have a connection there.
And how about the usage of the models for real-time rendering? I mean, are they just CAD models, or do they come textured and usable in a real-time rendering setting?
Currently, our platform supports 3D viewing with the mesh only, meaning that you can get the shape and drag, move, rotate this in the browser. We are constantly improving and developing the product, including the viewer. So basically, everything that today can be done in any CAD software, whether it be AutoCAD or SolidWorks or Inventor or whatever, will be possible in GrabCad as well.
Okay, thank you. And next, I would like to ask on stage Olli Rajala. He's the lead technical director and co-founder of Anima Vitae, and he's been the driving force in Finnish animation for the last 12 years. Olli.
Thanks, Ville, and sorry for barging in on the stage. I was worried about setting my stuff up. So, apes and blocks of foam. Silly title. Hopefully, it will make a bit more sense soon. So we're an animation studio. We've done a couple of these, whole lot of these, and at least minute-wise, even more of these. And if you look at, there's 233 episodes of It's About That. That's not a typo. It is really 233, and also Pasila, many minutes. And both of these shows are very dialogue-driven. And so the first things we did at Anima around 2000 was to automate these fairly tedious tasks. And yeah, we recognized the vowels from recorded audio and yeah, automated lip sync. But there always was a little bit of problems of detecting the consonants, and that's why the lip sync kind of lacks a bit of rhythm. So how to improve? Yeah, we got this idea that why not create some kind of a lip sync device. This kind of hand puppeteering movement is quite natural for animators when they start discussing about stuff. Okay, then he says like this. So the idea was, why not record this open-close movement somehow and maybe create some stylized rhythm to the lip sync solution. So here's our first prototype. Yeah, there's blocks of foam for you. There's a bend sensor. That's the open-close movement, and there's also a rotation sensor inside there. So we thought that maybe some kind of a head tilt movement would be useful. Soon we pimped it up to this 1.1 version where we added distance sensors. So now we had also 2D positional information, and we also added these knobs which could be attached to facial stuff or something. Okay, gotta test it. Quick test character, round up a bunch of animators. 3 tests, rhythmic test, lip syncing test, acting test, and really positive feedback. And we realized that it's not just for lip syncing. It's still a bit shaky at that time, but hell, it's a first prototype and a really crappy one, so yeah, great feedback. I'm gonna cut this short. So now we had a new goal. Why not aim a bit higher? Go for a complete digital puppeteering solution. Get all axes of movement and rotation and a low latency, minimal noise. So the next prototype, we move on to using a magnetic tracking system, which gives really good accuracy and low noise. But we stick with blocks of foam, because they're awesome. So just stick those sensors into the blocks of foam, and voila, that's it. Here's an example of me playing around with the current evolution version of the system. And you can see there's no latency. I'm using my right hand on the puppet, and my left hand is triggering facial expressions on the keyboard. And as you can see, here we have the special Aki Martikainen version of the device, which is quite beautiful. Yeah. Pretty expressive, and I'm not a master at this. So, what about real productions? The first one was this Daily Apes thing, which we did for the World Expo, sort of the Finnish part of the Finnish pavilion. And it's 8 times 2-minute webisodes. And it's basically these 2 apes promoting Finland. And yeah, they're still available at dailyape.com. Here's one episode of those, or part of it.
Female president. Equality is very important in Finland. A lot of countries don't have equality, but Finland is actually one of the most equal countries in the world. We have a female president.
Hello from Sweden, you friendly neighbors over there in Finland. Did you know that we in Sweden have a king and a queen? Our queen Silvia is a female too.
Fabulous.
Yes, she is.
Look, I'm talking about women's rights, that they're equal to men on all levels. Finland is a good country to be a woman in.
Yes, but Sweden is a good country to be Swedish in. In Sweden, we have Volvo and meatballs. Can you say, Swedish meatballs?
Swedish meatballs.
Okay, let's get it there. So, what did we learn from this? It's working with the system it's really fun. It's like playing with a toy in a good way. The immediate feedback encourages you to experiment with ideas, to take retakes and try out ideas. And you really can do also real production with it. The Daily Ape thing finally evolved into Apina Tasavalta, the Ape Republic. It's the concept was adapted to fit Yle's political satire slot, 17 times 15 minutes. And to go there, we wanted to simplify the characters even more to suit the style of motion which we were getting out of this system. And yeah, and we found out that it really tends to favor this kind of Muppets-like design more. Here's a random scene from one episode.
Verensokeri normaali. Refleksit kunnossa, ei kohonnutta lämpöä.
Entäpä karvapeite ja hampaat?
Kunnossa. Mahalaukun tähystyksessä ei näkynyt mitään ja sydänkäyrä näyttää hyvältä.
Perttu, miltä sinusta tuntuu? Ei miltään.
Eikö miltään?
Ei.
Tilanne on kriittinen.
Ja vaatii toimenpiteitä.
Mikä? Mitä? Kaikkihan kuulosti olevan kunnossa.
Ei todellakaan ole kunnossa.
Potentiaalisesti kyseessä on uusi pandemia.
Mutta eihän Pertusta löytynyt mitään oireita.
Sehän tässä pelottavinta onkin.
Huoneen ovet lukittu, koeyksilö A345 sinetöity.
Kuka?
Teidän poikanne. Hän on täysin turvassa.
Miltä?
Liian aikaista vielä sanoa.
Kiitos nopean reagoinnin selviytymistodennäköisyys on jopa 37%.
Mistä?
Tutkimuksista.
Yeah, and here's the money slide. So if you look at the, okay, I'm not saying that we could compare this to Pixar quality, but there's a place for this kind of production. So a typical high-quality animation is 2 to 3 seconds per week. This Euro anim, like the Nico films that we've done, it's 10 to 12 or 10 to 15 seconds per week. Apina Tasavalta was 60 seconds per day. And our lead, Apenator, revealed that he could do 1.5 to 2 minutes per day at best. And yeah, I'm gonna finish up with some thanks. Aki Martikainen was the guy who really worked from the beginning on the sort of animation expressive side of things, and Mikko Pitkan is the production designer for all the Ape stuff. And also the entire Apina Tasavalta team and all test subjects. And I'll use the remaining 30 seconds to let you know that I need to catch a plane. So I won't be here after the break, so if anyone wants to have a chat with me, do it on the break. Yeah, thanks.
Thank you, Olli. Joe, ready? Yeah. Okay, so next up we have Joe Robbins from Unity Technologies. Company is originally from Denmark, and right now they are the world's leading gaming middleware platform. So whenever you're ready, the stage is yours.
Oh, power adapter doesn't work on my laptop. Okay. Yes, it is working. Excellent. So yeah, this is the talk. Unity, from indie game startup to international real-time 3D tool of choice. So yeah. And this is me with an MP5 submachine gun. Proving that playing video games does not make you a good shot at all. I killed a hostage. I shot them in the eye. It was terrible. So yeah, I'm Joe. I started out as a 3D artist, an animator, and then I became a developer using Unity around 3 or so years ago, 4 years ago, 5 years ago. And then I jumped over the sea to Copenhagen to join Unity, and I'm now a community evangelist, which is a strange job title. So yeah, based in Copenhagen in Denmark, although technically it's not Danish in some ways because the founders are from all over the place. But this is the kind of the size of the company when I first joined. So it was around 25 or so, and this was just before we got our first round of funding. So early days, I was living in the office for a couple of weeks when I first moved over, sleeping in the bedroom that we had upstairs and walking downstairs to go to work. But we soon got to the point where we were growing so much that the meetings that we were having in the bathroom were just not very convenient anymore. So we grew. This is, I think, 2010, I believe, in Montreal. And then we grew again. This is 2011. And this is from our most recent annual conference. We have a conference every year called Unite. Still going. So yeah, we are a lot of people now. It's been quite a crazy period of growth. So crazy that everyone's face is pretty much just a pixel on this screen right now. So for those of you that are thinking, what is Unity? The cat has the answers. So Unity is a 3D engine and a game development tool, but it's also possible to use it for any kind of interactive 3D content, and many people have. And we do a few things, really. Our initial kind of idea as a company was to democratize the process of game development and make it so that anyone who's got an idea for a game is able to pick up our tools and get started and realize that game. So that's our kind of our core philosophy, really. And it kind of mirrors the indie background that the company itself started with. The next thing is rapid iteration. We're very focused on being able to produce and iterate very quickly. So we've a lot of our focus has been on that. We also have a very nice asset pipeline. It's very easy to get your 3D content or your audio or whatever directly into the tool to start playing around with it. And we also have a very wide multi-platform distribution setup, so you can pretty much make your game once in Unity and deploy to PC, Mac, web, Flash, Xbox, PlayStation 3, iOS, Android, Wii, and many, many more that I'm already forgetting. So yeah, this is how it all began. This is the very first game that was ever produced technically with Unity. This is a game that everyone will be familiar with. It's called Goo Ball. It was only available on Mac. I don't think anyone's ever played this game. But yeah, this was how it began. This was how Unity began as a small company, actually called Over the Edge Entertainment at the time. And this was the very first game that was made with the tools. And soon after, the founders realized that they actually spent more time arguing and discussing about how to make the tool better than they did about making the game better. So they decided to release the tools. And then I guess the first major big company to pick up Unity was EA. One of their main first titles was Tiger Woods Online. But then it kind of covers all other bases. So we've got lots of interesting iOS games. This is Battleheart from a 2-person team. This is the Kerbal Space Program, which is super awesome. And it's following like an alpha funding model. And we have Endless Space, which is a game that was released on Steam. And this one's kind of curious. It's a project by NASA. So there's lots of kind of non-gaming things that have been produced with Unity as well. And coming up to more recently, Bad Piggies, which was very recently launched, uses Unity. So I'm going to ninja through the next few things. This is our company growing, offices by offices. There's a guy in Brazil, then we expanded to Asia, Stockholm there, quite a company in Canada. But as of now, we have just launched a new office in Helsinki. And I'm pretty sure I've forgotten an office somewhere on that list. And the actual map there is looking strangely like a very obscure reference that some people may get. So yeah, a quick bit about Unity Finland. We have a new office. We've got a team of 6 guys currently that are focusing on graphics, iOS and Android and testing, and we are hiring. So there's a couple of links there for people that want to maybe look at applying. It's actually a really swanky office. It's pretty nice. It's kind of cool. So what I'm going to do with the last remaining piece of time that I've got is show a quick demo reel, which I should just be able to fit in, I think. Yeah. So this is an interesting project. It was a real-time... Right, so we approached a normal, traditional film production house doing CG with the idea that we wanted to make everything that they were doing normally in a normal production cycle, but instead of doing it all offline, having it rendered online in real time. So we did a whole bunch of crazy stuff, a lot of which has made it into the most recent version of Unity, Unity 4. And this is the result. It might get a bit loud. That's 10 minutes, perfectly awesome.
Very impressive. Next up is Pyry Haulos. He's the Chief Technology Officer at drawElements, and he's the brains behind the drawElements quality program. Pyry has the unique experience of working on all levels of the graphics architecture, from driver implementation to game engines. Pyry.
All right, thank you, Willie. Can we have the slides showing? Right. Thank you. So this is going to be a bit more technical presentation than the previous ones. So I'm going to tell you a bit what we learned about shader compilers in mobile OpenGL implementations. A bit of background about drawElements as a company. Basically, we are a bunch of real-time graphics engineers that happen to love quality. And our main product right now is actually like quality assurance tool, analysis tool for OpenGL ES, OpenCL. And it exposes information about the implementation, such as what features work and how fast the features work and so forth. So as a result of that, we managed to collect quite a lot of information about OpenGL ES2 devices, and we thought that you might be interested in hearing a bit about that. So for today, we chose to tell you about shader compilers or information we have on shader compilers. So nowadays, practically all of the effects in games and so forth, they are written as small programs in GLSL for OpenGL or HLSL for Direct3D. And the GPU drivers ship the compiler since you can't, well, the GPUs are not binary compatible, so you have to compile those programs on the target device for that particular GPU. And mobile games typically use something like 10 graphics programs per skin or per whole game. On desktop, it can be as high as like 100 shader programs for a single skin, totaling thousands in a full title. And all of those are compiled in runtime on the target device, so the obvious questions then are how fast is that compilation? It, of course, will affect the application load time, startup time, and are there issues with the compilation? To answer the first question, we implemented recently a performance test set for the shader compilers. So for OpenGL ES2, and here are some results from common shaders in mobile games. The times are milliseconds. For reference, there's the green line, or orange line, it's how long it takes to render a single frame when you're rendering 30 frames per second. And as you can see, the spread is quite high, so some implementations all manage to compile all of the test shaders in less than 50 milliseconds. It's probably going to cost you something like 2 frames if you do that during rendering. And in some cases, for instance, the iPad takes 0.4 seconds to compile a like reasonable size shader. And one way that implementers are trying to combat this like long shader compile times is the shader caching. So behind the curtains, they are caching the compiled programs, so you don't have to recompile them the next time the application launches and so on. And the iOS has shipped quite good shader cache for a while. The funny thing with that is that for some reason it clears in a reboot, so the next time your user reboots his device and starts again your game, and he will then again suffer for the long compile times. On Android, it's been just recently introduced, and not all the GPU vendors have yet integrated it, as you can see. And one subtle thing in the shader compilation is that you should definitely know about is so-called draw time compilation. So on certain architectures, the driver wants to bake in part of the fixed function state, such as blending modes or vertex attribute setup, into the program. And for that reason, the implementation differs the final compilation of the shader until draw time, until the full state vector is known. So that can cause then like unexpected stalls during rendering when you are rendering with an already compiled program, but you are using a new state, so the program hasn't been specialized for that state. So as a developer, what should you do based on that information about shader compile times? So obvious one is to limit the amount of programs you're going to use. So if you can, if the performance budget allows it, use as generic programs as possible. Then another good reason for that is that program changes cost quite a bit on OpenGL ES2 implementations. And if the shader binaries are available either through offline shader compilers or there's an extension for querying the compiled programs from the implementation in runtime, effectively allowing to do like application-side caching. So, and it's actually in OpenGL ES3 specification, in core specification. And then lesson from the compile times, apart from them increasing the application load time, compiling shaders in rendering time is pretty bad idea, so avoid that. And it also means that if you want to make sure that all shaders are compiled, fully compiled, you should also draw with those shaders and preferably with all of the state vectors you're going to use. And the second topic was, are those compilers perfect? No. And in fact, with the current state of the shader compilers is that, well, with, let's say, C or C++ compilers, we programmers have pretty much learned to trust them, so usually it's us to blame when something doesn't work, but in the shader compilers, especially mobile space, it's not the same situation. We've seen lots of issues and different kinds of those issues. And I don't have much time to go too deep on that subject, but a couple of recommendations based on our findings in there that we can give you is always test with as many devices as you can. And well, no one has resources to test with every single Android device out there, so at least try to pick the test devices based on the GPUs they have, to have wide selection of different drivers and different GPUs. And then the GLES compilers, they are quite bad with complex shaders, so try to keep the shaders as simple as possible. Another good reason for that is, of course, like simpler shaders are faster. But a couple of features you especially should avoid is like loops and dynamic indexing. They are pretty badly broken based on our tests. The upside with graphics bugs or shader compiler bugs is that sometimes instead of the boring crash, you can get some pretty nice visuals instead. And to finish off, I've collected a couple of nice pictures from our result database to showcase what can happen. This is the first one, so this is quite simple shader actually. It's just directional lighting in vertex shader. And the special thing is there that the lighting has been put in a loop, and that loop confuses the compiler enough, and well, you see the results. On the left, there's what's rendered on the device, and on the right, what's supposed to look like. And the second one is from shadow mapping test case. So, well, the shadow is kind of strange looking in there. You could argue that it's actually cooler looking in the actual rendered image, but it doesn't change the fact that it's quite wrong. And the third one, from a skinning test set, this particle effect worked quite well until we added normal mapping to the object, and at that point the compiler decided to do something really crazy with the vertices, and well, that's what you get. Right, so thank you for being here. Thanks for Willie and the crew for organizing this. If you have any questions, we might have time for one or two right now, and of course come to see me afterwards during break, and we'll have the demo over there, and we also have booth here in the slush. So, questions? All right, you can always ask them later. Oh.
You guys are having a little booth over there.
Yeah, we are having a booth over there, so you can check out our stuff there. All right, thank you.
Let's do Jiri first. Let's do him first, yeah.
Oh, was it my turn?
No,
Sorry
go ahead.
Oops. Can Ville get some voice, please?
That would be awesome. Thank you. Okay, so next one up is Jiri Kupiainen, and after jumping from web to games and back all of his career, Jiri co-founded Rocketpack to bridge the two. And Rocketpack has been a part of Disney Interactive for close to 2 years now as their in-house HTML5 game experts. Jiri.
Thanks, Ville, for the introduction. I think I actually jumped in line. I think I'm supposed to be the next speaker, but I'm just so eager to talk about this stuff. So this is my effort to compress about 45 minutes worth of presentation into 10, so I'll just get right into it. And actually, unlike Ville said in the beginning, this is not going to be about the state of the art, because Disney is not really that kind of a company. We're kind of a mass market company. So I'm going to be talking about the reality of HTML5 games today. So there's a lot of excitement around HTML5 today. There's all kinds of opinions flying around, because on the other hand, you have Mark Zuckerberg, the CEO of Facebook, saying that picking HTML5 as the basis for their Facebook application was the worst technology decision the company ever made. And that's a company that uses PHP on the back end. So that sounds pretty serious, right? On the other hand, you see all these gaming startups, raising a ton of money, saying all kinds of crazy things about how they're going to change gaming. And of course, with Rocket Pack, we've been knee-deep in HTML5 games for roughly 3 years now. So hopefully, I can bring you guys a balanced picture of what's actually real today. So the obvious first question, can you make games with it? That's a great question. Yes, of course, you can make games with absolutely everything. So let's focus a bit more. Can you make Flash equivalent or native mobile quality games with HTML5? And it turns out that you actually can. We have made a whole bunch. Disney Interactive has made a whole bunch. We've even had third-party vendors make games for us. And all of these games have been played by crazy amounts of people who don't even realize there's anything special going on. And hoping that the net connection works, I'm going to show you a couple of them. And this is not going to be Pixar quality, so don't be disappointed. So here's a simple game. No audio, but whatever. Simple game we've been showing at Google I/O, Microsoft's Build conference, and nothing special going on. It's just a simple platformer, with some basic parallax effects. You get all kinds of bad guys, but I don't have the time to play that far. And there's nothing crazy going on here, except that the same game runs on everything, like everything you throw at it, right? And I'm talking everything from the Windows or the Microsoft Surface tablet to all kinds of Android devices, to all kinds of iOS devices, to desktop browsers, mobile browsers, blah, 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 right? Here's another one. This one is actually really old. It's been on the Disney.com website for a long, long time. And I don't think any single one of our visitors actually realizes that it's not Flash. And that was the whole point of the exercise, Nothing crazy going on. Stuff just works. So to answer that question, yes, it is possible to make these games, right? And and just reiterating on that point, it's not really about anything besides this, you can with HTML5 we finally can actually get close to the promise of Java, which means that you can actually just make a single game, just have a single product, single code base, and actually take that to every single platform out there. And actually, it's going to work. And with Windows 8, Microsoft even made HTML5 one of the official kind of first-class citizens of the Windows 8 application world. So that should hopefully tell you something. And of course, just kind of continue with that point, there's the whole promise of build once, debug everywhere, which is very true. But there's also some benefits that you get from working with web technologies, because oftentimes, if you make a change, you have to compile, you have to deploy to the device, you have to wait and wait and wait to actually see the changes. But with web technologies, you can just make the change and just refresh the page in the browser, and you'll see what the change did right away. That's pretty cool. There's a crazy big community around HTML5 and all the open web technologies. If you just go to GitHub, you'll see that JavaScript is probably the biggest language there today. There's a lot of articles, a lot of source code you can just dig into right away. One big thing for commercial entities is that there's no single vendor in control of the platform. So for example, once you finish your game, Adobe is not going to come to you like, oh, hey, by the way, it's a nice game. Do you mind paying 9% of your revenue? At least if you're Disney, you probably don't want to do that. Oh, what's that? That's nice. Thank you, OSX. Okay, kind of related to the previous point. it's kind of a rare situation where you have Microsoft, you have Google, and you have Apple all competing on who can give you the best possible platform. Like who can give you the fastest JavaScript runtime, the highest amount of features in the browser and everything. So that just means that like this technology is moving at a crazy pace right now. There's like every time there's a new Chrome release, which is like once a week, there's a whole bunch of new awesome features, and Microsoft and Apple try really hard to keep up with that. So for you, that's a big benefit if you decide to pick this technology. And I think that the biggest point is that it's a pretty safe bet to make that every single new consumer device that comes out in the future that has a screen will have a browser, right? And if it has a browser, it's going to be a better browser than the ones we have today, which means that your game will continue working on any and all new platforms that come out. If you have any Yola people here, you know we should talk. Any and all platforms that come out, and it's probably going to work better than it works today. And that's not a minor thing if you're going to make a long-term commitment or a big investment as we have with Disney. Right, so that's cool. You can make games, you know, it's really awesome. Yeah. But can people actually play those games? Because otherwise it doesn't really matter. Well, they actually can. So here's some numbers from Disney.com for this year. So beginning of the year, a bit over 60% of our visitors could play these games. Today, we're at over 80%, so that's a fairly major change in just 9, 10 or 11 months now. But the coolest thing is that if the trend continues, and this far it has been very reliable, we're about to hit 100% in May next year. So let's say you're planning to make a game, and you're assuming it's going to take half a year to develop it. Well, today is a good day to start with HTML5, because you can be fairly sure that once you're done, everybody will be able to play it. Of course, in reality, you always have those, you know, few percent of people who will not upgrade anything ever until their computer breaks down. But that's the reality of technology, always. Like, that's not specific to HTML5. Right, of course, it's not all roses. Pretty obviously, native applications will always have a performance edge. They will always have an edge in features supported. So natural, like if you're making the most cutting edge game ever, if you're making Call of Duty, you know, you probably are not gonna ever use HTML5. But of course, if you're, you know, Disney, if you're just trying to make mass market games, it might be a really good pick for you. One big thing is that HTML5 is actually not a single clear standard. Like when we say HTML5, we actually mean a crazy amount of different standards, proposals, drafts, and whatever. And all the browser makers implement those things differently, which just means that like the way you make a gradient in Microsoft Internet Explorer is going to be different from Chrome, which just means that you want to use a game engine to kind of get rid of some of the craziness. Maybe one interesting point for this crowd especially is 3D. I mean, we've seen some pretty awesome stuff today. And 3D is a problem because like today, maybe half of your desktop visitors will have WebGL, which is the web version of OpenGL. And the problem there is that Microsoft has never been a big fan of OpenGL, as some of you might know. So there are rumors that they might be willing to change their mind when it comes to the web, but that's not a given. Like, it's a political issue that we can't do much about, right? Another political issue is Apple. So Apple has had WebGL in iOS for years now, and it works just fine. But they decided not to give it to you, because what might happen is that people will just play games on the web instead of going to the App Store, and that might be kind of bad for Apple's business. So for 3D games, I would not rely on this technology today. I would just wait and see how the politics play out. But absolutely the biggest enemy of HTML5 is Google, which is kind of funny, because they make Chrome. So today, the biggest problem facing this technology is Android. And the problem there is that a majority of Android users are stuck on ancient versions of the platform with no upgrade path. And Google did a really, really bad job there and screwed everybody over with that. But the reality is that like most of Android users are going to be using an ancient version of the platform, and they don't have an upgrade path. So they're not going to be able to play the high-end HTML5 games. Of course, you know, there are solutions. You can use some kind of an accelerator, but there will be a trade-off. Like, you won't get access to all the features anymore if you do that. But still, it's doable, but you'll just have to keep that in mind. So I have about 30 seconds. It's probably not going to take that long to read this slide. But that's the point. That's the reality of HTML5 games today. Thank you.
Thank you. And next up, we have the dynamic duo, Julius Tuomisto, who's the CEO, and Janne Karhu, the lead developer, who make up the core of Delicode. They're a Finnish startup focusing on delivering software, algorithm, and design for Microsoft Kinect and similar devices. And I guess you have your own hardware setup over there.
Testing. Hi. Okay, this will take just a second of your time. While Jan is setting up, thank you, Ville, for the introduction. So I might as well say a few words. So Delicode is a small Helsinki-based startup, actually Helsinki and Turku-based startup, and we develop stuff for the Kinect and similar devices. There's a bunch of these devices coming to the market right now. Intel just released, in collaboration with Creative, another device. The Leap is coming out. We just received SDK for the Leap. This is a kind of a hand tracking device. What we're going to present to you today is two things. We'll showcase something called Animate, which is a program that we've been developing for a while. But to start with, we'll actually show you a little video of a gaming concept that was created using this technology that we've been developing. So this is called Connected Stories. This will take 2 minutes, and then we'll work out how we did this using Animate and using Blender, which is an open source game engine.
In Connected Stories, the child becomes an active part of the storytelling experience. A story in the series inspires the child to do what comes most naturally to them, telling a story through their own movement and voice. While doing so, the child keeps developing both their mental and physical capability. A key aspect to the concept, the printed book represents a continuation of the same story outside the digital realm. After experiencing the interactive version, children will be even more excited about their parents reading to them before bedtime. The interactive version can be updated and hidden content can be uncovered by showing certain pages of the printed book to the sensor device at key times. All storybooks in the series feature a unique storyline, hand-drawn illustrations, and professionally spoken dialogue. The first Connected story is a timeless Grimm Brothers classic, Little Red Riding Cap.
Okay, this was the minute version, actually. This is the better version. Okay, so what we did with this concept was that we wanted to kind of see if Animate, the user interface or this program that we've been creating for the Kinect and similar devices could be used to kind of accelerate the process of making these kinds of games for the Kinect. Because the problem that everybody knows for the Kinect is that a lot of the gaming concepts that are available for the console, for Xbox, are not so good. And we kind of thought that maybe this could actually help people develop these sort of game concepts. What you're going to see now is live. So I'm a little red riding cap right now. And this is all done in the Blender game engine. And maybe I'll hand over to Janne so Janne can give a little explanation of what's happening behind the scenes.
Yeah, hello on my part too. So basically what's happening is that our software Animate is running continuously on the background. And it's currently tracking Julius on the stage. And then transmitting the tracking data through OSC into the Blender game engine. So